July 29th, 2025, 2:43 p.m. A powerful quake struck near Russia. Hours later, something even stranger happened. Deep beneath Mount Rainier, St. Helens, and Hood, the ground began to pulse in perfect rhythm. For 6 tense hours, the Cascades moved as one, then fell silent. No eruptions, no answers. So, was this the first warning of something far worse? On the afternoon of July 29th, 2025, a colossal magnitude 8.8 quake erupted off the coast of Russia's Kamchatka Peninsula. The quake was so intense that it triggered coastal alarms in areas as far as Alaska and Japan, warning of tsunamis and aftershocks. However, if you thought that was scary enough, then you need to hear about what happened next. Thousands of miles away, something far stranger was happening. Something that could leave even the most experienced scientists completely speechless. In the hours that followed, seismic monitors across the Cascade Range that stretches from Mount Baker in Washington all the way down to Mount Shasta in California began picking up faint rhythmic pulses. Normally, these would have passed as just other ordinary tremors that these monitors pick up every other time. However, something was entirely different this time. These tremors were perfectly timed. They often came in waves every 11 minutes, as if each volcano was responding to an unseen signal deep beneath the Earth. Inside the Cascades Volcano Observatory, scientists immediately went on overdrive, watching in disbelief as data from multiple volcanoes pulsed in sync. What was even stranger is the fact that there was no magma movement recorded, no rising gases, and no swelling ground. Instead, all that could be seen was a steady and repetitive rhythm that made no geological sense. This pattern was too structured and deliberate. To those scientists, it was as though the entire mountain chain was breathing together. The question that now lingered on their minds was, were the volcanoes simply reacting to the global shock from Kamchatka's quake? Or was there something deeper going on? More of a hidden network connecting them beneath the crust? Eventually, the signals faded, leaving nothing but a trail of confusion and curiosity behind. However, the discovery that the scientists made later seemed to undo everything else they thought they knew. Adamant that this event needed to be studied even further, the team from the Cascades Volcano Observatory started liaising with those from the U.S. Geological Survey, as well as the Pacific Northwest. One thing was clear. The data in front of them did not fit any known pattern, and therefore, they were largely in the dark. After extensive analysis, they pinpointed something in Mount Rainier's data. At first, a faction of the scientists believed that this might have simply been Earth's echo. This faction argued that the quake that rocked Russia might have sent pressure waves racing through the planet. It is this pressure that might have briefly turned the mountain into a part of tuning forks. This idea was largely unsettling, but still made some sense. On the other hand, there is a faction that argued that this was a signal of something deeper. According to this group, it was possible that these were not echoes, but subtle shifts of molten rock and superheated water miles below the surface. They described it as a slow and silent dance that volcanologists call slow slip movement. Yet, as more data poured in, these hypotheses were challenged, once again throwing the scientists into the dark. In addition to the 11-minute gap between the waves, the team also realized that gas sensors near Rainier's crater had shown typical emissions of steam and carbon dioxide. Shockingly, there was no trace of sulfur-rich gases to suggest that fresh magma was rising. In other words, the pulses were real, and the volcano was reacting. But it was not gearing up to erupt. This immediately became a double-edged sword for the scientists. If there was no eruption brewing, what exactly was making the mountain move in rhythm? And then the twist got even bigger. Researchers in Japan and Russia reported discovering similar pulses beneath their own volcanoes. This discovery pointed toward a planetary scale of connection. If that was the case, Rainier may not just be a solitary peak. It might be part of a living network of mountains quietly communicating across continents. By now, the mood was a mix of awe and unease. Had the planet itself just revealed that it was more alive and responsive than anyone ever imagined? But before we reveal the answer to that question, please take a minute and subscribe to the channel. That way you won't miss any future updates about this topic and many others. To answer that, we need to first understand Mount Rainier. For starters, this mountain is nestled right atop one of the most active geological fault lines. It is also part of the Great Cascade volcano arc, formed over millions of years, as the oceanic Juan de Fuca plate slides beneath North America. It is this subduction process that forces rocks to melt below. Then, the resulting magma feeds the volcanic mountain and turns it into a majestic yet volatile giant. Scientists have classified Rainier as stratovolcano, meaning that it's a volcanic mountain made up of alternating layers of lava flows, ash, and fragmented rock. Its composition makes it particularly dangerous due to the steep slopes as well as viscous magma that can produce violent eruptions. In fact, its eruptions easily dwarf those of gentler shield volcanoes of Hawaii. In other words, Mount Rainier is primed for devastation. And what better way to answer that question than by looking at what history has taught us? You see, about 5,600 years ago, Rainier suffered a massive collapse known as the Osceola mudflow. This resulted in a huge portion of its summit giving way. Then the resulting debris avalanche, mobilized by ice and steam under the summit, rushed all the way to Puget Sound, leaving thick mudflow deposits that underlie towns today. The scale of that event illustrates that even periods of apparent calm don't guarantee safety. The mountain might seem safe, but deep beneath, it may simply be gathering energy. More recently, Rainier has been whispering rather than roaring. As recently as 2005, a significant earthquake swarm in 2025 logged north of 1,300 tremors in just a few weeks. This activity was more than any other previously recorded in the history of the mountain. While no eruption followed, scientists concurred that this was a strong reminder that small changes like subtle gas emissions or a burst of ground heat might seem benign. However, they must not be ignored, as they form part of a larger and far more ominous story. Even more concerning is what this incident has revealed, and how that changes everything we thought we knew. Seismometers track every tiny tremor. GPS units measure ground motion in millimeters. Gas sensors detect even the slightest changes in volcanic fumes. And satellites map heat and deformation. All of these feeding into real-time data streams. Yet, despite all of these, scientists have admitted that forecasting a volcanic eruption when it comes to Mount Rainier might still be a formidable challenge. The thing is, this volcano has proven that it does not follow a neat and predictable pattern. At times, it may arouse with weeks of warning signs, and at other times, might barely register a whimper. This brings us to three things: evacuations, emergency routes, community readiness. The fact that Mount Rainier looms above densely populated regions like Tacoma, Puyallup, Ording, and Enumclaw, and beneath its summit sits enough ice and debris to unleash lahars that can race down valleys with terrifying speed, means that a lot must be done to ensure that everybody would be evacuated in the event that it unleashes its fury. Also, we cannot overlook another critical fact, that is the disruption that would be caused by a major eruption of this mountain. This is based on the fact that the Cascades are located in areas with highways, airports, water supply lines, and power lines. So where does that leave us? The monitoring systems might give us a perception we are more prepared than ever. Yet this recent incident has also exposed a glaring concern. These systems might also be blindsided and fail to give sufficient data to help us know what's going on. For now, Rainier is quiet. But quiet is not the same as safe. Far from it. Quiet might mean that it's gathering momentum. And as of now, no one knows when that momentum might present itself in the form of an eruption.